This conference will now be recorded.
So right, we'll start with the MapReduce, and in HBase we left with data loading techniques and Java API, and of course some zookeeper commands. So in another session we'll see everything, right? So we'll start with MapReduce. So once we're done with this MapReduce, we can complete even the UDF functionality in Pig and Hive as well, so that everything will be the leftovers will become will be covered.
Sure,
That's
sure.
fine, right? So coming to this MapReduce, initially just we'll see the basic things. We'll understand what you mean by mapper, reducer, driver, and what is the template if you want to implement a business logic with that, right? So after that, we'll understand the old API and new API differences. So as a developer, it's up to you which API that you want to implement and you want to use, right? So the based on that, you can choose either old API or new API. Everything is remains same. What happens, some classes and some, I mean to say, some methods which are not used or they are deprecated in the new API, and the way of the calling classes methods also got different. Okay, we'll identify anyway what's the difference between the old API to new API. So same word count program I'll show you in old API as well as new API. So once we're done with that, I'll show you a few examples on advanced MapReduce also. And for your self-exploring purpose, I'll share a few more MapReduce programs. So once we're done with that, we'll go with UDF, and of course we'll cover the big one, what we left, the HBase, advanced topics in that. That's fine. Right, let us start here. So this is our agenda. Like initially we identify what is a MapReduce and how it works. We'll try to get some explanation for that, and I'll show you hands-on on all the API as well as new API. That's it. So coming to this MapReduce is a functional programming model, and internally we'll be using the quickset algorithm whenever you want to process the data. So here, of course, so we can do even not only the MapReduce process. Apart from that, you can go with some partitioning and sorting, and whenever it's possible, partial aggregation also you can perform at the mapper level, right? So all these things can be performed here. That's fine. So where exactly you're using this? So initially, once the Hadoop frameworks came into the picture, so they referred, and they for storage they has given something like an HDFS, a distributed file system is proposed, and on top of that to process the data, because you're storing structured data, unstructured data, and semi-structured data. So different categorized data that you're storing on top of the HDFS. So to process such data, they need to have a framework. That framework is nothing but the MapReduce. Okay, that's only available once this Hadoop into the market. Of course, after coming and after arrival of this ERN, right? Not only MapReduce, you can go with the multiple processing frameworks also. You can go with the Spark, you can go with Tej, or multiple frameworks can be introduced to process the data. But earlier we just having only the MapReduce pattern. So whenever you're giving certain data, even though you're using Pig, Hive, HBase, whatever it may be, that has to be converted into the series of MapReduce process, then has to be executed on top of the data which is available on HDFS. So once the earn into the picture, nothing but the second generation Hadoop, then multi-tenancy, what we call and what we refer, it's introduced. So you can use the Spark also. Okay, same word count program you can process with the help of Spark framework also. Okay, so anyway, that introduction of this Spark and all, that time I will show you how to run the MapReduce program. I mean to say not MapReduce, the word count program on Spark environment, so that you get some idea. Of course, it need a knowledge in Scala, I do agree, but just to get a comparison and how it process, how you're going to process that really in Spark environment, I'll show you that. But anyway, coming to this, basically this is a functional programming model, and internally we'll be using the quicksort algorithm to process the data. And coming to the limitations part, it's good for the batch data processing, right? So already you're having some archive data, maybe some you're having historical data that is with you, Then you want to do some analysis, like you want to find out the maximum and minimum temperature, because already the historical temperature data is available with you. Then you want to process, right? In a similar fashion, you want to go with some other analysis. Then whenever you're referring to batch data processing, that time MapReduce sorry, is a good choice for you. But whenever you're looking for some real-time data analysis, right, it's not possible. The architecture is quite it's different. Multiple phases will be there, and this programming model will not suit for that, right? But it's only good whenever you're having terabytes of data to get processed and you want to finalize the result. That's it. And coming to the data types, okay, coming to the data types. So in Java, just we are having integer, long, and float, double, and all, right? In a similar fashion, in Hadoop, the equivalents of these Java types are nothing but the int writable, long writable, float writable, like the way. So this is known as Hadoop generics actually. Hadoop generics you can call, or the simply the Hadoop data types. Nothing but the equivalent of the Java. Because the programming and the interface, everything, having some pretty much similarities with the Java programming. So even that's the reason the data types also pretty much similar here. So whenever you want to talk about the int, so it you have to think in int writable like that, right? So where this can be used, I said okay, it's good for batch data processing and all, that's fine. But in real time, where this is going to be used, or where this model is mainly used, a lot of use cases will be there, but just I'm talking only few cases here. Like Google is using this for index building. Like whenever their data is deployed into multiple servers and they want to do some indexing on the data, so first level indexing and second level indexing, nothing but the multi-level indexing that can be possible with this MapReduce. Similarly, article clustering. So that's a big like Google is getting news feed from different sources like BBC, CNN, and other, right? So the news has to be collected and has to be given a reference. And also whenever a particular thing is queried, like maybe you're looking for some audio or video, what it may be, or textual data in the Google search, the appropriate information has to be displayed, right? That's the reason what exactly the Google is doing, the index building, because all the way it's getting different data sources, right? So that has to be clustered and you'll be getting the information like that. So for that, it has to do some multi-level indexing and all that will be prepared by this MapReduce pattern. Similarly, Yahoo is also doing for the same thing. Apart from that, it's using the same model for spam detection also. For example, we'll be generally receiving some mails, right? Like you won some UK lottery for 1 million euros and you have to deposit 1,000 euros initially to receive those 1 million euros and all. For example, you receive that mail to your inbox and you just made that as a spam because it's a suspicious mail. It cannot happen. And that's the reason what happens, the once the moment Naresh kept that as a spam mail, so Yahoo makes sure that this particular mail is not at all reaching to the other Yahoo users. For example, I'm also using the same Yahoo email ID, right? Then it's not reaching to my inbox. Whenever I'm getting such mail like you won just UK lottery or US lottery with this many euros or dollars, so that particular mail tend to the spam folder, right? That's about spam detection and all. In a similar fashion, Facebook is also using for data mining, ad optimization, and spam detection. So these are the some application areas what we can talk about MapReduce. Coming to the anatomy of MapReduce, how it really does, how it really works internally to process the data. So MapReduce only knows the things in the key value pattern. So you say anything, okay, to the MapReduce only key value pair. Input is key value pair. Once again, the output is also in the form of key value pair only. Apart from the key value pair, it doesn't understand anything. So whenever you're having certain data, so it's your responsibility. So we are using some classes to prepare the input data. Sorry. So maybe you're having some structured data or unstructured data, semi-structured data, whatever it may be. To process the data using the MapReduce, the main condition here is the data should be in the format of key value pair. Okay, nothing but a hash map. So once you just have your data in a key value pair format, you can supply the same thing to the MapReduce. So initially the mapper process will do the job, then followed by the reducer. So anything you just supply, everything has to be there in the key value format. Look at this. So here the map is having an input as a key value pairs, and it provides the list of key value pairs because it is processing multiple mappers. For example, your data is distributed into 10 blocks. So 10 mappers are running in parallel and they're providing finally the list of keys and value pairs. That's the reason why always this mappers provides a list of key value pairs. So because your data is distributed to multiple things, right? Multiple blocks, 10 blocks, 10 mappers in parallel. For example, 100 blocks, 100 mappers in parallel, like the way. Sorry. Come into the reducer. So when the once the mapper is provided the intermediary output, this becomes the input to the reducer. Once again, this guy also processes the same thing. Keys and list of value pairs. Finally, finally the aggregation job will be done, and you be getting the list of key value pairs, right? So this is a basic thing. What exactly happens? The main thing here you need to understand whenever you want to process the data using MapReduce, that the input should be in the key value format, and mapper provides the intermediary output as once again key value format that will be inputted to the reducer once again the same thing, and finally you be receiving the output also in the key value format only. That's a main thing you need to understand here. Now, how this can happen internally, we'll understand with a simple thing. So just here we're talking about the word count process. Okay, you're having certain data like this HBSI, for example. This is a sample data that you can consider, and you want to get a count. Okay, you want to just get a count for that, how many times HBase came and Hive came, MR came, like the way. Nothing but you are trying to get the word count, occurrence of each word on a given data set. So for this particular problem statement, okay, so what are the various phases will really involve internally to get this output? So this is the input, right? You just having the data HBS, Hive, MR, Pig, MR, like the way, and this is the final output. So to get such a result, what is the phases, right? Look at this. To simplify the discussion, I'm using generation 1, where my block size is 64 MB, and here I'm having the total file size as 192 MB, for example. So right, so once I'm having input of 192 MB data, that's going to split into 3 blocks of 64 MB each. So 64, 64, and 64. So just consider I'm having a data in here, here, and here. So initially I just split the data. Of course, here I'm saying I split the data, but actually this is the job of your MapReduce framework. So as a developer, we are not doing anything. Okay, so we are just, our business logic will be involved in this mapper and the reducer phase. Of course, there is some other phases also, I'll let you know later. Okay, so this splitting and shuffling and sorting, so for this we are not at all applying any business logic. So that's a responsibility of your framework. Nothing but your MapReduce framework will look into that. So just this is your input data. That's all. Just to provide it 192 MB data like this. Now what happens? This data will be split into 3 unique blocks like this. 64, 64, 64, like the way, for example. Now what happens? Initial key value pairs will be prepared because mapper cannot understand the data if you're supplying like this. Okay, so initial key value pairs will be prepared once again by your MapReduce framework only, then will be supplied to this MapReduce. Sorry, this your mapper code here. So now you here the your mapper business logic will run, and finally it will go to the next level, reducer. In between, you'll be having shuffling and sorting also. If you look at here, So what happens? We will go one by one here. So initially we just provided HBase Hive MR. We'll talk about this later. So now what happens? Our mapper is doing preparing list of key value pairs. So what's the keys here? HBase, Hive, MR, all these will be acting as a keys for us. So that's the reason this is the key and comma one, nothing but its occurrence is one here. So HBase comma one, Hive comma one, and MR comma one. That's it. So this is from block one. And after that, from block 2, it prepared p comma 1, p comma 1, mr comma 1, and finally hbase comma 1, p comma 1, hive comma 1, like this. So this is what happened in the mapper phase. So our framework is preparing this initial key value pairs. Based on that, mapper is providing the sort list of keys and values. Now what happens? There is something like shuffling and sorting phase will be done. Why we need to do the shuffling and sorting? Because in an Hadoop environment, our cluster size is very big. For example, in our rack, we are having 10 machines, right? Nothing but just consider you're having 10 machines, so nothing but 10 data nodes you're having. So these data nodes are having blocks, right? So we are not having any guarantee that this will go to the first machine, second machine, like the way. So data will be randomly distributed, right? So maybe this block is available in machine 1 and this is available in machine 7 and this is available in machine 2, for example. Once the data is distributed like that, the mapper has to prepare this phase, right? And it's preparing this hbase comma 1, h comma 1, MapReduce comma 1. That's fine. So before reaching to the reducer, with the help of this shuffling and sorting, what will happen here? Look at this. We'll talk about the combiner and partitioner later. Just understand. So now based on your key, what is your key? Here HBase is key, Hive is key, MapReduce key. So all these are the keys. So based on that, shuffling and sorting will be done here. Nothing but here HBase comma 1, that's fine. And we are having one more key here, HBase comma 1 here. So this is the key and these are the list of values. So this appeared one here one time and one more time here. Similarly for a Hive, here it appeared one time and it appeared one time here. Similarly for MapReduce and similarly for PQR, right? So like this way, what happens? Keys and list of values prepared with the help of this shuffling and sorting phase. Sorting is nothing but automatically the data, the keywords will be kept in an order here. That's fine. So now everything like shuffling and sorting phase is done. Then what happens? So finally, it's been reaching to the reducer level here. So it's doing the final aggregation here. Like this is the key and this is the value hbase comma 2, Hive comma 2, mr comma 2, and p comma 3 here. So finally you're going to get the result. Now look at this. One second, I need to say one more point here. So I said simply we're writing just logic for this mapper and reducer, but how this will happens, this is the 192 data, 182 MB data, and how it spread across to multiple blocks, or how it created initial chunks like this. That is happened with the help of input format class. So this class takes the responsibility. So just giving the data, right? So that has to be split into your as per your block size. Maybe your block size is 64 MB or 128 MB or anything. So based on that, what this input format class will do, it will distribute the data into multiple chunks, right? Here simply I said your framework will do this distribution, but internally who will involve? Nothing but the input format class. So what happens? It splits the data and keeps the data into multiple blocks. That's fine. Here I said mapper can understand only the things in the key value format. It cannot understand if you simply say HBase or Hive and MR, it cannot understand because this guy needs only the things in the key value format. So who will prepare this initial key value format for the mapper? The answer is pretty much simple, the record reader. So record reader is the guy who is preparing initial key value pairs from the given data. You have to mention some data. So from the data, right? The initial splits will be taken care by the input format class. So once the splits are happened, your record reader will involve, and this guy will prepare the initial key value pairs to the mappers. Then of course shuffle and sort, because your data is distributed to multiple nodes. So shuffling and sorting happens, and after it's reaching to the reducer, and of course in this diagram it has not shown, then once again you be having a record writer before reaching to the output format. Okay, so record writer will be there and it will be writing the output here. Here you got the output, right? This one, h base comma 2 5 comma 2, like the way. So there is a record writer also there, and finally based on the output format that what you specified, you be getting the output. That's it. So these are the phases in general what happens in a MapReduce pattern. But in addition to that, we are having combiner and partitioner also here. If you look at here. So what is a combiner and what is a partitioner here? These two are optional, but this can be involved whenever we need. Okay. If you look at this diagram, so here the user code or the business logic will be only be involved in this mapper phase and the reducer phase. And rest is no way, like we are no concerned with we are no shuffling and sorting and splitting. So here as a developer we are not involving, or we are not writing any business logic for that. We're just writing logic for only mapper and reducer. So splitting and shuffling and sorting, all this will be taken care by the framework itself. Apart from that, we do have few more things here, two more other phases, like a combiner and partitioner. So what's a combiner and what is a partitioner? We'll see that. Anyway, these slides I explained, so I'm not going much with that. So coming to the combiner and partitioner, what exactly this? Combiner can be viewed as mini reducers. So what is that mini reducers? We'll understand. At the same time, they perform a local reduce before we distribute the things to map a result. That's fine. Fast workload further, of course. They're just taking away the burden from the reducer. That's fine. How it will take the workload, we'll see now. So once we talk about the combiner, we'll go back to the partitioners concept. Back to this slide. So here we're going to introduce the combiner concept. So what the combiner will do? So these combiners are the local reducers, nothing but here you're having three blocks, for example, three blocks of data that you're processing, nothing but three mappers involved here. So for each mapper, a local combiner will work internally here. So whenever possible, based on the keys, it will provide the aggregated result here itself. For example, here these three are individual keys, HBase, Hive, MR, so you cannot do any aggregation job here. But look at this block here, p comma 1, p comma 1, and mr comma 1. So what you can do here, here itself you can do the local reducer job simply by saying p comma 2 here itself, right? So this is nothing but the local reducer job. Here overall we'll be forwarding or taking the things to the reducer level. But before that, if you can introduce the combiner, what it will do, so based on the key, it will generate the aggregated result in the block level itself. Okay. So here, for example, you're having three mappers. For three mappers, you'll be having three combiners, which will be working independently. So one combiner for this, one combiner for this, and one combiner for this. So based on the keys, the local aggregation will be done here. Nothing but the local reducer job will be done here. And coming to here, nothing to do. HBase comma 1, because these three are the individual keys. And like the way here also we are having three individual keys here. So that's about the combiner. And what about partitioner here? So partition is saying, so something like, which determines the reducer is responsible for a particular key. What do you mean by that really? When it's going to be happen and how it can be implemented in real time. See here, what happens here, once you process the data, you'll be getting output like this, right? HBase comma 2, high comma 2, MR comma 2, and peak comma 3. Just consider you are not interested with the output like this, because all are keys, right? HBase is one key, high is one more key, MR is a key, and peak is also one more key here. So based on these keys, you want to go with a partition. Like in the first partition, you want to keep HBase. And the rest, second partition, you just want to keep the thing called high related stuff. And in the third and third partition, you want to keep all the remaining keys, whether it may be MapReduce or big or anything else. So what we are doing here, based on a particular key, just we are redirecting the output. That's it, not more than that. Okay. So here HBase is a key. So HBase, whenever HBase is coming 2 times, 3 times, or 4 times, or 100 times, whatever it may be, that a partition will be created and HBase related stuff will be maintained over there. Similarly, for high, we just consider we have created one more partition for high. Then what happens? So high, how many times high came, that will be given in the one more count, one more partition. And rest all words, nothing but the rest all keys will be segregated into particular partition, one more partition. Like this, the distribution takes place here. And coming to this combiner and partitioner, we have to write the business logic. Of course, for the combiner, no need to write any specific logic, just we need to recall once again the reducer functionality. The logic what you implement a reducer, that will be same used by once again by the combiner. So no need to write any specific logic for the reducer, but if and all you want to go with the combiner, then that time you need to introduce the business logic. Okay, so these are the keys and these are the values, that's fine. But for this particular key, I want to create a separate partition. I don't want to combine with anyone. Like the way you, based on your choice, you can create multiple partitions and you can keep the data. See, same thing what we performed right in Hive in the dynamic partition and the manual partition also we have seen. So in your related stuff and everything we are keeping in a separate partition, and yours related we are creating one more partition. Similarly, in the point of sale data, what we worked on customer data. So for state wise, we just created, okay, I mean as a category wise, we created some partitions. So like based on that, once again, country wise and state wise, we just created buckets over there. Just what we did, we distributed the data based on the key. So what's the key over there? Country is the initially category is the key, right? Because we are having multiple sports categories. So category is the key. Based on that, we just diverted the output, or we just distributed the data to multiple partitions, isn't it? So here also same thing, but you are writing a business logic. That's it. So there we are not at all writing any business logic in the Hive while we're discussing about the manual and dynamic partitions. Simply we're specifying in the table definition. That's it. Partition by, and you're giving your key. That's it. But here in this MapReduce pattern, we need to write the business logic. Just you need to go with the template and you need to call the rest of classes and methods. That's it. So right, before going further, Naresh, please let me know if you have any queries.
No, they like good work, man.
Fine. Sorry. Now, coming to this, once you are having the mapper, reducer, and driver, right? You're ready with the mapper, reducer, and driver. We need to create a jar file. I'll show you that practically. Don't worry. So we have to go with a driver. I mean to say jar file. Okay. So of course, in your code, it's up to you whether you want to go with the combiner, partitioner, and everything, right? So in any MapReduce program, mapper is compulsory and the driver is compulsory. Okay. Driver is nothing but you're just providing the configuration information, nothing but the schema. So what we can call where you are giving the input, where you are expecting the output, right? And how you want to process, what is your input format class, output format class, your mapper class name, reducer class name, nothing but you're just providing all the information, the data that you want to process, that will be kept under the driver. So in any MapReduce program, you'll be having a mapper and driver. These two guys are mandatory, right? Reducer is optional. Of course, you'll be having the reducer also based on the data, but some cases will be there. In Hive also I have shown you, right? If you recollect, there we implemented a concept called map side joins. In that, intentionally we are making reducers as 0. So we're not going any with the reducer. So everything will be performing on top of the mapper, right? So same concept here known as a distributed cache. So here also you can implement in the MapReduce straight away. You can write a business logic where you will be making set number of reducers is equal to 0. So everything will be running on the mapper itself. So same concept, if you recollect, in Pig we called as a replicated join, right? So there also in Pig what you're doing, we're performing the join operation, everything on top of the mapper itself. Nothing we're doing on top of reducer level. So that's the reason I'm saying, in general, it's a common. You'll be having a mapper class, reducer class, and the driver class also. But in some specific scenarios, we may not have the reducer. But most of the use cases, you'll be having the mapper, reducer, and driver as a mandatory. At the same time, this combiner and the partitioners are the optional. So if you like to introduce, yeah, you can go with that. And you are not interested with, you can. It's up to you. As a developer, you are having the freedom, whether you want to go with the combiner and the partition or not. Now, that's fine. After once you have the mapper class, reducer class, driver class, combiner, and partitioner, everything, we had to create a jar file. So why we need to create a jar file? Why can't we run as a standalone programs? The simple answer here is, if you're giving that if you're giving without the jar file, then there is a dilemma, because a lot of programs are running in the cluster level, so your job tracker will not understand. Okay, so what is this mapper reducer, whether you're having what you can say reducer or not, or whether you have introduced any combiner, or whether you just introduced any partitioner. So such information will be really clumsy to the job tracker, because job tracker has to give the details to the task trackers, right, to work this mapper and reducer and everything. So that's the reason once we create the jar file, what happens? Nothing but just you consider you're posting some articles to your friend, like there is some birthday function, you're just sending articles to your friend. So what you're doing, you're just taking a neat you're just packing them neatly, right? You're keeping all your things into a particular box. You're using just a cotton box, and in that you're just keeping all your things, the gift articles and all. Then you be covering with some neat package cover and all. Then you're writing your address and all. Then what happens, that will be received by the recipient, and he is signing on that. Okay, then you be getting some idea. Okay, with the product delivered without tampering, right? Everything is received. If you're not keeping in them in a box, then what happens, there is a chance of misuse, or there some places will be misplaced, some items will be misplaced, right? So in a similar fashion, once we jar that map, and nothing but you're just putting a okay kind of a box, that's it, we're tagging that, that's it. It's a mapper class, reducer class, driver class, and everything. So this will be reached to the job tracker. So job tracker will unjar this, nothing but it will open this particular pack and reads initially this particular driver program. So once it reads the driver program, then it will have the idea list of items and all. For example, you have sent a courier. In the courier box, you'll be getting the items and all. So once you open there, you'll be getting the invoice, right? In that they specify. So these are the items you are ordered, and these are the products we delivered. Like though you will get the invoice, right? In a similar fashion, this driver also will consist the same information. What is your order? Like what's your mapper class name, register class name, driver, and the other stuff, and everything will be intimated to the job tracker. Now the job tracker is having complete idea, then it will give the details to the like nothing but initially it gives the mapper logic to the task trackers followed by the reducer logic, right? So for this, what you have to do, you have to create a jar file. For any business logic you can consider, there is one minimum, one mapper, reducer, and driver. Reducer sometimes optional, right? Coming to this mapper, try to understand the template here. So how to write the mapper code here? That's interesting here. So our mapper code, what it will do, it reads the input files as a key value pairs. Already we understood this, right? Everything has to be specified as a key value pairs only and emits the key value. So the input is key value and output is also key value once again. And what this mapper class will do, it has to extend its parent class. Our mapper class, right? Our mapper class, nothing but the child class, what you're writing here, it has to extend the MapReduce base class and has to implement the mapper interface. So that is the main job of our mapper class here. So what it has to do, it has to inherit, nothing but it has to extend the MapReduce base class, nothing but its parent class, and it has to implement the mapper interface. So here interface mechanism is like something like, and I will tell you later, like some of the properties are ruled out in the general, I mean to say new API and all. Okay, something like whenever you're extending the map, I mean to say your child class is getting the features from your parent class. So what the properties it will have? It will have its own properties at the same time the parent class properties also. But coming to the interface, it's not like that. It's purely optional. Okay, you may have or you may not have. Got it? So whenever you're extending the base class, must and should the child class has to have all the properties. But you're implementing the interface, then there is no such guarantee. You may have or you may not have. Oh, it's not a blueprint kind of thing. When you're talking about the class, it's a blueprint. It has to follow the same pattern. I'll give you one simple thing so that you can understand. For example, you bought a car, okay, you purchased a new car and all. In that, like they be giving some options to you, okay, something, some accessories. Later also you can fix. It's not a problem. There is some compulsory, some mandatory things will be there, and some options will be there. For example, for a car, wheels, engine, steering, accelerator, clutch, brake, all these are mandatory. So you can't say these are all optional. But coming to the stereo system or navigator, reverse parking, I mean to say sensors, right? So all these are optional. You may have or you may not have, like the way your AC variant. So you can fix later also. To run a car, those are not mandatory, right? To run a car, those are not mandatory. But if you want to fix them in later also, that's possible. So that's a thing what you can expect from the interface here. So those are not mandatory. Features will be provided along with your class. So in your feature, you may extend those properties, or I mean say you may implement those properties, or you may not also. Got it? So that's the reason what our class has to do. It has to extend the marriages based class. Our child class has to extend the marriages based class, and it has to implement the mapper interface. This is the first job. And the mapper interface always expects the four generics as a key value pairs. So two for input and two for the output here. So the first two parameters define the input key value and the second two define the output key value. So mapper is taking the key value pairs, input key value pairs, right? So at the same time, it's providing the intermediary data as also key value pairs only. So here I said four. So four generics K1 V1 K2 V2. K1 V1 for input, K2 V2 for output. That's it. And of course, some common libraries also be there to support the mapper class. Apart from the normal Java, of course, Java.io exception, these are all related with your Java stuff. So apart from that, we need to have certain libraries also to support our mapper class and all, right? So what are they here? So import org.apache, Hadoop.io, and Hadoop MapRed. So like this, you need to design your template initially. And
this is something like, based on that, this template is prepared. Look at here. So public class myMapper is extending the base class and which is implementing the mapper interface. That's it. So here these are the generics K1, V1 and K2 and V2. Okay, so myMapper, this you can give anything here. Public class Naresh extending the base class and implementing the mapper interface with the 4 generics. That's fine. And this is about my map function. So map function is having key, value and the output collector and reporter. So this also access 4 things here. One is a key, value and the output collector and the reporter. So what for this output collector? Because your mappers are generating the intermediary map data, right? So mapper 1, 2, 3, 4, all these guys are generating the intermediary output. So to collect that, we will be using the output collector class here. Okay, output collector. Similarly, we are having the reporter also. What for this reporter? So while processing, you're getting some information on your console, right? This many bytes are processed, this much data is processed, this is started this time. So you'll be getting some information, right? Which is crawling on your, you know, I mean to say command line interface and all. That information will be fetched with the help of this particular reporter. Okay. So this is the basic thing that you need to keep in mind while you are designing your mapper template. So just what you have to do, your mapper has to extend the MapReduce base class and it has to implement the mapper interface with these 4 generics. So this is for key, value, and this is for key and value. First 2 for input and second 2 for the output here. Key 1, value 1, key 1, V1, sorry, value 1 and key 2, value 2 here. And this is our mapper function. And here we said, apart from the key value, we'll be talking about the output collector and report also. Right. So what is the output collector here? So this guy, what it will do, this is responsible for to writing the intermediary data which is generated by all the mappers. And coming to the reporter, this guy just records the things, right? How when this process is started, how many blocks is processed, right? So like the way. Now here, look at this. I'll try to explain one more point here. Here we said someone just understand this so that get some idea. Let me take to this to a notepad. Right. Now if you look at this, okay, I'm talking about this. Right. So what for this? So this is for v1 comma value 1. Similarly, v2 comma value 2. Right. That's fine. Right. So these are the 4 generics. What you're referring here. If you look at this data type, why this is long writable, why this is text, again, why how this key becomes the text and how the int-writable becomes the value here. So we'll understand with a simple thing. So initially what we have given here, back to this, right? So this is, we're having certain data, right? HBase have MR like the way, for example, you are having certain data. Hi, how are you? Right. So then what happens? This cannot understandable by your mapper. So initial key value page has to be prepared and that will be generated by the Hadoop framework itself. Already we discussed. So here, based on this, a byte offset will be generated and that will be treated as your I mean to say key here. For example, byte offset, that's something like, and I'll tell you in the numeric values. So this is started somewhere in the 0th position, right? So this is started somewhere in the 0th position. So H 0, 1, space 2, 3, 4, 5. Suppose this is ended somewhere in the 13th. Maybe in the 14th position, it's starting one more line. I'm good. I'm good. Fine. So it's ended somewhere in the 20, 20 for example. Again, the next line is starting somewhere here, 21. Okay, like this, for example. It's going on. So what exactly here we need to understand? Sorry. So this byte offsets, right? 0, 14, 21. These are prepared as a initial keys here. So the data type what we provided for them, long writable. So this is key. And this is the data types that they belongs to. Right. So then what happens? You be getting, after processing, you be getting some intermediate data, right? Like your high came one time, how came one time, for example, or came one time, you came one time, right? So then what happens? This is the intermediate output which is generated by this first line. So this becomes here key and the one becomes the value here. So that's the reason here the key value pairs are text and int writable. Have you noticed that? So here if you see, I'm not talking about the rest of the lines. Okay, to simplify the discussion. So here you can see this is for my K2 and V2. So these are the data types that they belongs to. So text is the text and this is the int writable is the value what you're having to get process the data here. So that's the reason, right? Here by implementing our mapper, we said long writable text, text and writable, nothing but we just provided the data types for all these generics K1, V1, K2, V2, nothing but the K2, V2 and all. Got it? That's the reason here that's long writable and text, and that's the reason why here the text and int writable. This is what we done with the help in mapper. What about our reducer here? We'll understand with the reducer also. So reducer, what it will do, it code it this reducer code reads the outputs which are generated by different mappers. So input is also key value pair and output is also key value pair. That's fine. And this register is also has to extend the MapReduce base class, nothing but this is the parent class, and it has to implement the reducer interface. So always having the freedom. It may or may not, right? Similarly, here the reducer interface also always expects 4 generics from your side, 2 for input and 2 for output. Okay, and the keys are writable comparables and the values are writables, of course. And these are some libraries that we need to provide for our reducer class apart from the Java, like org.apache hadoop io.star and org.apache hadoop.mapred, like the way. So this is about the template here. Look at the template. So public class my reducer has to extend the base class and which has to extend the reducer interface, and these are the generics. And here also same thing, reduce function has to go with the key and the iterator. Okay, so key and why you're going with the iterator? Because it's receiving the intermediate data from the multiple mappers, isn't it? So that based on the key, that loop has to be iterated. How many times high came, how came, peak came, high came, HBS came, like that. You need to iterate the loop, right? So for that, that's the reason in the reduce function we'll be writing key, And the iterator, nothing but the occurrence of that each key 4 times, 6 times, like that way, right? And we do have the output collector and the reporter, same as how your earlier the map function is having here. So this output is for the final output, and this reporter is to record the evidences, like how many when it started, how many blocks of data got processed. All this has to be maintained. But if you look at this, apart from this, if you look at this, okay, if you look at this, the MapReduce is implementing this MapReduce interface, but look at the data types, what it's going to have. Right here we'll be writing. One second, something went wrong. Yes. So why here? Look at this. It's having long writable and text, but this guy is having text and interwritable and text and interwritable. So once again, this k1 b1. This is the key 1 value 1 and key 2 value 2. That's fine. Right. This I'm talking about the reducer interface here. One second. I'll keep here itself. That's why. Now, if you look at here, so this will be passed to, this is the mapper output, right? First of all, mapper, sorry, mapper output, right? So like this, multiple mappers will generate, of course. Now that's the reason here it's receiving as these data types, text interwritable, text interwritable. So this becomes the input to your reducer. This already we studied, right? Discussed earlier. So this becomes the input to your, this particular mapper output is input to the reducer here. That's fine. Then this is from first mapper, for example. This is from mapper 1. Just consider mapper 1. Similarly, you just have one more mapper output like this. For example, this is from your mapper 2. Then what happens? Finally, you have to give the consolidated list here, or aggregated data, like hi came 2 times, how came 2 times, or came 2 times. For example, you came 2 times. So this is the final output. Final output from the reducer here. That's it. So how this is nothing but the key 2 and value 2. So what are the data types here? Text and interwritable. That's the reason here the input and output pairs will be text and interwritable only. Got it? Right. So this is about, you need to understand here. So always your reducer class to extend the MapReduce base class, and it has to implement the reducer interface with these generics, and your reducer function should have the key and iterator. So key is nothing but what you're sending, like HBase, HiPeak, like the way, and the iterator. So it has to iterate that values, and finally you be getting the count, like hi 2 came, how are you, it came, how came 3 times or 10 times, like the way. And what for the output collector and reporter? Output collector is for the writing the final output from the all the mappers. The reporter is to
record the evidences, what happens exactly, to what time, how many bytes of data got processed, and how when the register process is started, and finally when it got ended, right? The information what you want to display on the console. And what about the driver? So this is something like, heart of the your MapReduce program. So this driver only will have the main method. We know you in Java, right? Like even though you're having 1 lakh code or 1 million lines of code, where from where your execution starts, where exactly you're having your main method. From there only it starts the execution part. So this driver will have the main method here, right? And we'll be giving all the details, like where you're providing the input, where you're providing the output, with the command line arguments, what we call one for input and one for output. And if you want to go with, if you like, already the output is exiting on the same location, it's going to give an error, some warning message. So output directory should not contain any archive data or the previous data. Okay. At the same time, what are the other stuff we need to specify here? So everything, like, you have to give all the information. Apart from that, we have to set the configuration job also, and that will be triggered with the help of job configuration object here. So we need to set the job first of all. So once we set the job, we need to run the job also. Okay, nothing but you need to configure the job first of all. What job you want to run? For example, here you need to run the MapReduce job for a word count program, right? So that is, for that we have to configure the job. At the same time, how it's going to be triggered? Maybe you're having a mapper, combiner, partitioner, or so you're having a lot of other steps in the input format classes and everything. That's fine. But this has to be triggered, right? We need to have an action event, right? That will be done with the help of this job configuration. Got it? That's fine. And of course, this is the common libraries which generally needed to run your driver program, like org, Apache, Hadoop MapReduce, Hadoop IO, and MapReduce, all the other stuff. So this is the template that you can feel. So look at here, I just specified my driver class and I'm having my main method, and I'm creating my job configuration object here. I'm giving a name to this. You can give any name here. And I'm just writing what is my mapper class name, what is my reducer class name, what is the input and output formats. Like input is text, key one and value pairs, and output is the iterable here. So this is the key and this is the value here. Similarly, this is for my reducer. What is your input and what is the output here? Key and value pairs. And what is your mapper class name? What is your reducer class name? And text input format class and output format classes. So where you're providing your input, like command argument 0 means command line input 0, where you're providing the input, and args 1, so from where you're expecting your output. So this we are using, right, command line arguments. Same thing, we just have the reference here. So finally, once you're having all the details, finally you need to run the static method. Of course, we are using the static method here, job client dot run job configuration. So this will be triggered. So based on that, now job tracker will have the complete details. Okay, so it will have the details of your mapper class name, reducer class name, where you're providing the input, and where you're getting the output. Nothing but the where you're expecting the output, what is your input format class, and what is your output format class, right? And your key value classes, everything, every information will be available in this driver class. So once everything is there, we need to create a jar file and we need to run our job. That's it. Of course, this is the same thing. I have given some more things for the input format and output format classes. So apart from normal key value pairs, these are the other things you can provide, like sequence file input format, n-line input format, key value text input format, text input format. So text is the default input format. Okay. So what are the other formats that you want to see? Like the way this is for your interface and this is for your DB input and all. So like the way, based on the data that you're providing, you have to go with the different input format classes, and these are the respective, the I mean it's output format classes based on the input format classes and all. So right, some other information I have provided here. So whenever you're writing your MapReduce program, these are mandatory and this will be available in the Hadoop common.jar, because generally the Eclipse, not only Eclipse, any IDE will be in the Java perspective. so it can understand the things only in the Java, right? But if you're writing the code in the MapReduce, so you're it's not having any idea. You're writing mapper class and you're writing the MapReduce base class and you're writing about the mapper function. You are using all the way the mapper interface, but these are really Greek and Latin to your Java, because Java doesn't know what exactly this. That's the reason we have to go with certain packages also. And please do remember, so in our business logic, we need to extend this libraries, Hadoop common.jar and Hadoop client core jar. Okay, so this has to be, we need to add the additional or external libraries. Those external libraries will contain these packages. Okay, I'll show you this practically anyway. So once we're done with that, once we created the MapReduce job, then it will run at the at the cluster level. So what we'll do now, of course I have provided some additional information, so please go through this once this presentation is shared to you. So we'll take a sample data, and on the sample data we'll run the MapReduce job. In that time I'll show you how to create the jar file and all other stuff, and we'll back to the slide and I'll tell you what exactly this. Where is that? Just a minute. Okay, we'll add this. Why we need to add it, then you will understand. I'll tell you. So let me start the virtual machine. Mm, right. Let me verify whether I'm having any data set here. No. Just a moment. I'll take the data sets. Let me take this part. Right. Right, I'm having some other also, but what we'll do, we just run the word count program here. What is this? Oh, just let me verify. Okay, this is one. Okay, we'll see that later. So what's the business logic? This is a simple thing. Okay, this is not required fairly here, right? So this is a simple word count program. Just I want to show you. So we're talking about a lot of things, right? So this is about my mapper, and this is about my reducer. Finally, I just have my driver also. Three classes. So you can run this program separately. You can go with a simple single program also. It's up to you. It purely depends how you want to implement. There is no mandatory. Right, we'll go one by one here. This is about my driver. So if you observe here, just be configure the job and you set the name for our job, word count. Here you can give anything. Then just to specify the output key class, value class, and everything, mapper class name, and the text input format and output format, and command and arguments to provide the input and to provide the output. Finally, we are running the
static method to run our job. So that's all about our driver. What about here? Even we are having the main method also. Look at here. So execution starts from this only. Then what about my mapper class? So this mapper is extending the MapReduce base class and which is implementing the mapper interface, right? And here I'm just assuming I'm hard coding this. I'm assuming each word will have occurrence of one time at least, right? In any given data, a word can be repeated at least one time. So that's the reason I'm taking a one as a variable and just I start hard coded here. Then after that, what I'm doing here, I'm using my mapper functionality here to take the key and value. And as I mentioned, now do have the output collector and report also. This output collector, what it will do, it will be recording the intermediary outputs which are generated by the different mappers. And I do have the reporter object also, which records the things, what happens, like that way. So the line initially I'm defining the data as a line, it's a variable, and there's the data type what I provided as a string. I'm converting, maybe some words will be in the lowercase or uppercase, whatever it may be. They will have now all the things in one particular use case. Then I'm using the string tokenizer by which I'm tokenizing the things. So what exactly there in this line? So welcome to Hadoop world. So welcome to Hadoop world, like the way that will be, this string tokenizer will break the things here. Then based on that, I'm giving a count. I already hard coded this right here one. So based on that, I'm just giving a number. So welcome is one time, to one time, Hadoop one time, class one time, like the way that will be given here. And what about my reducer here? Reducer is also same thing. It is extending my MapReduce base class and implementing the reducer interface here. Similarly, as it is receiving input from the multiple mappers, here I'm using key and the value will be iterated. So key will be your H base or a high, whatever it may be. And the occurrence, because it's getting the count from different mappers, nothing but different intermediary outputs, that has to be iterated, and I kept the same thing here. So I'm taking a variable called sum and I'm initializing that. So just I'm giving a count, whether I'm having any counts or not, right? So finally I'm writing that key and the value, that's it. And finally, once I'm having this static method, my job will be triggered. Then what it will do, it will be getting a count on the input, given input data and all. So now we are ready with the business logic. So what we'll do, we'll take a sample data on the HDFS and we'll create a jar file with this mapper class and reducer class and driver class. Then we'll run the jar file, that's it. And to do all this, either you can do as a normal Java program, okay, without taking any help from the IDE. Suppose you're good in IDE, yeah, you can work from the IDE also. Suppose you're not good in IDE, outside this IDE also, you can create the jar file and you can run the jar file. It's up to you. But to simplify the discussion, what I will do is I'll run from the IDE. So here Eclipse is already there for me. Here the link is provided for me, right? Just click on that. It's taking some time. Get over. Just Okay, right. So what I will do is I just create a project initially. Just go to this file and new, and either you can go with the Java project or project. So I'm going with the Java project. Suppose you're having Scala, you'll be having a Scala perspective also in your Eclipse. But at present in this machine, I don't have any Scala. Right, I'm just having Java perspective here. So I'm creating a project here with the name Naresh. Right, just say finish and right click on this and go with a new and create the class. So just provide a name for this word count. Say finish. So either you can use the import mechanism, or what you can do, you can just copy and paste the business logic or the code simply here. It's up to you. Okay, either you can import the complete project from the outside, or just take this. For example, I'm having already the business logic, the class file. So I'm selecting this and I'm taking this to my Eclipse. So right. So what I did here, I copied my mapper class, register class, and driver class and everything. So you're getting some problem here because here I'm having the capital W, nothing but the just I will correct this. Yeah, I just rectify that. Then there is no problem here. You can see it's got class name got changed. But if you look at here, it's having org Apache Hadoop configuration IO MapReduce utilities and everything. So this Java is not able to figure out what exactly those packages. So for that, what we need to do, we need to add libraries, external libraries. So what are the libraries? This Hadoop common.jar and Hadoop MapReduce client code.jar. So right. So we need to add these two jars here. So let us add. How to add? So click on your project. So here you'll be having that build path and go with configure build path. Then here you're having multiple tabs, right? Sources, projects, libraries. So here you select the libraries. Then say add external jars. Here a lot of things will be there, but you have to add the Hadoop jars. So where those jars will present, so those will present in under user home. So here I'm having my installation folder Hadoop 2.3.2, right? So here libraries native, not here, just a moment. Right. So what are the jars we need to add here? One is a Hadoop common and other is a Hadoop MapReduce. So we'll add those jars. Right. Here you can see Hadoop MapReduce client core. This is the one jar. So add that, and we need to add one more thing. From the common. Here you can see Hadoop common 2.3.2. This is the version, that's it. If you don't know which particular jar has to be added, you can select all the jars. So as mentioned, here you can see the Hadoop common.jar and Hadoop MapReduce client core, both are added here. Okay, both are added here. One is a common and a common core also, both are added here. Client core and common. And after that, go to this order and export. Here, just say select all. That's fine. Now, once we added those jars, nothing but the libraries to this, now you can verify that you just left with the cross marks. and you'll be getting some warning messages because these are the deprecated. This related particular library is this package is nowhere used in this business logic. But no worry, don't worry about this particular, see it's saying very clearly it's deprecated, no way it's used, but not a problem. You can leave your business logic as it is. Now what I had to do, we are ready with the mapper, reducer and driver. We had to create a jar file. Let us create. So right click on your class file or the program, and here you're having export. Then go to Java, select jar file, then say next, and you got your project here. Let's check that. And where you want to create your jar file. For example, you want to create on the desktop. Say the same thing here. On the desktop, just put some name. Naresh WC1. This is the name I want to give. You can give anything. And please don't put any extension here like .jar and all. So right. So what I did here, I just selected my thing and I just given the destination also where I want to create the jar file. Then you say next, next, and here you have to select your main class. So just say browse, and this is the main class. Maybe at cluster level multiple programs are running, so you have to select your appropriate class name. That's fine. If you accidentally forget to select your main class, please don't worry, you can give the same thing in your command also while running, while running the work on program. I mean to say in the terminal also you can provide that, but it's always good thing to select the main class here itself, right? Without this, if you created the jar file, still no need to worry. We can mention in the command line also, right? But this is a good thing to select the main class from here itself. So no need to do any additional things in the command line. That's it. That's fine. Of course, so don't worry about the warnings here, right? So we just created a jar file with this mapper, reducer, and driver. Look at here. I'm having this jar file now with me, right? So what I will do, I will run this jar file and I'll get a count, occurrence of each word. So let me verify whether I'm having any sample data or not, first of all. So just I'm ready with my business logic. So I will verify any data set is available in the HDFS or not, first of all, right? So let me verify any data. What is this data model? We'll take some plain data. Okay. We'll take one plain data to understand the things. Okay, not a problem. What is the sample 28? Yeah, this is fine. So you are having something height. This is my test file height. This is my test file like this. So now we'll get some count for this occurrence of each word. How many times high came, this came, is came, like the way. So this is our input directory, sample 28. That's fine. Now just open a terminal. Okay. So where is your jar file? Jar file is there in the desktop. So go to desktop, right, and run your jar file. How to run that? So Hadoop jar and the jar file name and your input sample 28 and space output. What's output? You just provide any name. So I'm saying Naresh WC1 OP. You can give anything. So one folder will be created now with a name called Naresh word count 1 OP. right? That's it. This is the very simple thing. If you forget to give the main class while creating the jar file, so you have to mention here, because this guy doesn't understand where is your main class. We know that, right? The execution starts from the main class only, and you just forget to give that main class. Still no worry, just specify the main thing here. That's it. So Hadoop jar and followed by your jar file name, and this is your input directory location at HDFS, and this is the output directory location in the HDFS. That's it. So just run this. Right. So just verify here.
Yes.
Yes, Naresh OP1, yes, we have provided. Not this one. Not this one. This is a very old one. We have given in a lowercase, I guess. Yeah, this one. So if I appear 3 times, height appear 3 times, this way is 1, and this is 3, like the way. You just bring out the list, that's it. So finally, we are able to get the output like this, right? Now, if you observe here, we don't have any information. That's the main drawback with the old API. So we don't know whether this output is final output is from the mapper or reducer. We don't have any such information. Okay. So if and all you're using the new API, you will be getting a letter like R or M. So R means this final node is from the reducer, and M means this final output is from the mapper. But here we don't have such information. So if you're using the new API, then you will get the same thing also. So now what we'll see, how to go with the same program with the new API, and we just identify some differences, right? Some important differences we'll identify, and we'll just run the same program in new API, and we'll see how it works. Let me open the new API. Just a moment. Somewhere. Yes. We'll understand the difference between the old API to new API. Right. So in the old API, just we are writing, the map class, which is extending the MapReduce base class and implementing the mapper interface like the way, and after that in the mapper function, we'll be writing key value pairs and output collector and reporter like this. right? And the package also, here you can see this org.apache Hadoop MapReduce like this. And coming to the new API, the noticeable changes here are, so just we need to write the class is extend the map class, that's it. Okay, public class map class extends, that's it. So here we don't not having that particular interface concept here, which extends the mapper class, that's it. And in the mapper function also, we don't have these two, output collector and reporter. So these two merged into context object here. Okay, here have the class and this object. So into this context object now these two guys are matched. So no need to write the output collector and reporter. The jobs earlier, what exactly these guys are performed now into this context. Okay, right? That is the one more change. So what are the changes here? First thing, earlier we are writing public static class, of course. Map class is extending the base class and implementing the mapper interface. Now it got changed like this. Map class extend the parent class, that's it. And this is the new API. So look at this. Earlier we just have the map rate, that's it. So whenever you want to write or you want to prepare your business logic using the new API, you have to go with this MapReduce, not with the map rate. So you have to have the complete thing here. So at the same time, in the mapper functionality and the reducer functionality, okay, in the mapper class and reducer class, we don't have these two guys, output collector and reporter, because in the new API, these guys are merged into context. Okay, that's it. So that's the reason I mentioned here. Same thing will happen applicable for the reducer also. At the same time, earlier we just defined the class, I mean to say the job, and finally we are running the static method here. But in the new API, it's somewhat changed here. This is how you are instantiating new class, configuration class. Then the job is defined like this, new job is configured like this. Then we are setting some properties for your job. Then finally you are saying job dot wait for completion is equal to true. This is the action event here. Earlier purely the starting guy, which is running your complete MapReduce program. So of course some other changes I just mentioned as a table here. You can give a read and you can go through like this. Most of the points I explained here. Okay, but there's a noticeable changes like earlier map rate, now MapReduce. Earlier output collector and reporter, now just a context, right? And job running the job is also different here. How you can run here, there you be having a job configuration class in the new thing, and just you're having a configuration static object in the earlier thing. And here just we have noticed we are not getting any information whether this output is from the mapper or reducer. But in the new mapper API, I'm saying sorry, not mapper API, in the new MapReduce API, you'll be getting this. If you'll be getting M, this means that this final output is from the mapper. And if you're getting R, that means that your final output is prepared with the help of reducer. That's it. Okay. And reduce method also passes values via java.lang iterable. Earlier we are using iterator, right? So in place of that iterator, now the things changed to iterable. That's it. So like that, we are having some changes, and apart from that, there is no problem with this. So just I have given some explanation for that, right? That's it. So these are the changes when you're talking about the new API to old API. Okay. So this is the package. Please do remember the package and think about this context. And what is the job class? How to define the job class is also different. So and here interface is mandatory in the new old API, and purely this is a optional one in the new API. There is no compulsory to go with the interface and all here in the new API. So look at the business logic, how it changed into new API. Just a moment. And let us open the one more same program but with a new API. I'll show you. Yes, just open this program. We are not changing any business logic. That remains same here. Only thing here Look at this. Earlier only the map read. Now this is MapReduce. And look at this. Class map extends mapper. That's it. We're not writing MapReduce base class and the story. You are not writing any story over here. And no more, that reporter and the other stuff. Just those guys are replaced with this context. So same thing is applicable for your MapReduce as well here. Here you can see this. We don't have those things. Here also your reduce is extending the reducer. That's it. We're not writing using reducer base class and the interface like the way. It's like this you're writing here, right? And coming to this driver, you can see just mention the job. Initially your configuration job configuration object details you're providing, and you're setting some name, and you just giving all the names, mapper class name, reducer class name, and everything. And command arguments we just specified here, right? Where you want to go with the 0 transfer input and this for output. And here writing some business logic also. If and all output is provided, okay, in the given path, if output is already there, then we're asking to delete that and create the new one. That's it. That is the advantage. So for example, okay, we'll see that later. So what is the thing you need to understand here? If you're not having this particular line, then what happens? If and all your output directory is already present, then you'll be getting an error. If you're running any WordCount program, any program, not only WordCount, any program, MapReduce program, if you're running, you're going to get an error. Like in this particular area, already you're having the output. Please give the new location. That's the reason if you add this particular line, then what happens? What is the advantage of this? So if and only you're having any output, previous existing output, that will be erased and this will be there. So you don't get any errors. And finally, we are running with this job.wait for completion true. That's it. Okay. So earlier we are using a static method to trigger this job. Now let us take this business logic here, my Eclipse. What I will do, I will use the same package, same project. I'm not creating any project. Instead of that, what I will do, I created one more class here. Yes. And put some name to this, new WC. Right. So just paste here the business logic. So now it's not showing any errors. Why? Because it's already having that packages, right? We just added already. Only it's having issue with this class name. I have given as new wc.j, but it's having a different name. Just change that. Right, we just change that. Now it's not a problem for us. As usual, just we create the jar file. How to create a jar file? Just go to the export, and here just set the jar. Say next. Select your project and say browse, and just put a name. Here I'm giving Naresh WC2 on the desktop. Please don't take away that extensions if and all any extensions there. Then you just select the main class. Two classes, two methods are there, right, in the same project. So select your own thing. I'm showing the earlier one also. Don't worry about the warnings. So new thing is new jar file is created with the name what? Yes, new wc1.jar. Right. Now we said always we have to give the new location, right, to run our MapReduce jobs. For example, this Naresh WC1 output is already there. If we run this, what happens? I'm not running any new job. I'm running the old job only. That's what I want to show. Look at this. I got an error. Why I got an error here? Look at here. SDFS localhost, and this is already existing, so please give the new one, right? If you give the new just now we created one more jar, right, with a new API. There we implemented logic. If and all any previous directories there with the same name, just erase that. So we'll use the same thing. So I'm changing just my jar file name, wc.jar. This is what we created just now with a new API. This one. Where is that? Yeah, this one. wc2 jar. And I will keep the input and output as same. Okay. I'm not changing this. Then what happens? We'll see whether it's giving an error or it's giving the output in the same thing. See now the job is running, right? It's not giving any error. That you can give in the old API program also. Don't think that is a specific feature for this program. Just I want to show you the difference. That's the reason that line is added in the new API and not added in the old API. If you want to have the same thing, you can add the same in your old API as well. That's not a problem. So right, it's completed the thing now. You're going to get an output. Okay. So we'll go and verify the same thing. Here you can see narration. Oh, not this one. Again, I just want the same thing. Here we are having that narration WC1. Same old, only I have given. Look at this. Earlier we don't have this R, right? Just we are having part hyphen zeros. But now as we run with the new API, we got the difference here. It's saying R here. And of course, output will not be varied. It remains same based on the input, but this is the negotiable change that you need to identify. That's it. So based on your convenience, right? So you can write the program, I mean to say the MapReduce program in the new API or as well as the old API also. But you need to have the idea of your templates, how to implement the mapper, reducer, and driver, and creating a jar file with the main class, and where to select the input and output. And what type of input that you're providing and what type of output that you're expecting. Those things have to be specified very clearly in your driver class. That's it. Okay, so that's all from my side today. So we'll see that at few more programs, advanced MapReduce programs in our next class, and parallelly we'll be working on the HBase remaining stuff. Okay,
Yeah.
and yes, right. And today what I will do is I will share one document to you related with the HBase Java API. So please go through the table and just get an idea of the classes, methods, and you know the interface, everything here, which we'll be using in the HBase Java API. Okay, that will
Sure.
be usable stuff for you. So if you have any queries, you can check with me before ending the session.
Not right now, just
Okay, just give a try. I will be sharing the complete things for you. Give a try, and once you're good with this, you can try with the remaining MapReduce programs as well. Right? Fine. Thank you. See you.